Dear students, in the derived expression for velocities of two bodies after collision in one-dimensional elastic collision. So in this one-dimensional elastic collision, consider the two bodies m1 and m2 are moving with initial velocities u1 and u2 and final velocities v1 v2 after collision. So that means if the condition is u1 is greater than u2, then only the collisions will possible. But in the one-dimensional elastic collision, in one-dimensional elastic collision, both momentum, and kinetic energy will conserve. So first we'll write the by the conservation of momentum, by the conservation of momentum, total momentum before collision equal to total momentum after collision. So that means m1 u1 plus m2 u2 equal to m1 v1 plus m2 v2 here. So that means we write m1 u1 minus m1 v1 equal to m2 v2 minus m2 u2. Here common here m1 u1 minus v1. Here common m2 v2 minus u2. That is with the equation 1. So now by the conservation of kinetic energy, kinetic energy, total kinetic energy before collision equal to total kinetic energy after collision. That means half m1 u1 square plus half m2 u2 square equal to half m1 v1 square plus half m2 v2 square. So in this, write half cancel in all the cases, all the terms, right? m1 u1 square minus m1 v1 square, that is m2 v2 square minus m2 u2 square here. So you can common m1, that is u1 square minus v1 square, that is m2 common v2 square minus u2 square. So let it be, this is equation 2. So from 1 and 2, equation 2 by equation 1. So what is the equation 2 here? So that is nothing but a m1 of u1 square minus v1 square, m2 is v2 square minus u2 square by m1 of u1 minus v1, that is m2 v2 minus u2 square here. Yeah. So here m1 m2 m2 cancel, a square minus b square can be written as a plus b into a minus b, u1 plus v1 into u1 minus v1 by u1 minus v1. This is v2 plus u2 into v2 minus u2 by v2 minus u2. So here u1 minus v1, u1 minus v1 cancel, u2 minus v2, u2 minus v2 cancel. So that means finally u1 plus v1 equal to v2 plus u2 here. Now we write u1 minus u2 equal to v2 minus v1. So velocities approach before collision equal to velocity separation after collision. So now in this equation 3, from this equation 3, you can write the v2 value in this u1 minus u2 plus v1. This is 4 equation, that equation 4 in place in the equation 1. Equation 1. What is the equation 1 here? M1 1 u1 plus m2 u2 equal to m1 v1 plus m2 v2 here. In this conservation of momentum equation is substitute. So then m1 u1 plus m2 u2 equal to m1 v1 plus m2 of substitute u1 minus u2 plus v1. So then what will happen? See m1 u1 plus m2 u2, we can multiply with m1 v1 plus m2 u1 minus m2 u2 plus m2 v1. Now v1 tends to send the other side and remaining the right another side. m1 u1 plus m2 u2 minus m2 u1 plus m2 u2 equal to right m1 plus m2 into v1. So in this m1 u1 m1 plus m1 u1 minus m2 u1 plus m2 u2 plus m2 u2 2m2 u2 it is coming. So m1 plus m2 into v1. So finally you can common u1 here. What is that? m1 minus m2 into u1 plus 2m2 u2 equal to m1 plus m2 into v1. So therefore write v1 is can be written as m1 minus m2 by m1 plus m2 into u1 plus 2m2 by m1 plus m2 into u2. So then from this equation again you write v1 value v1 equal to v2 minus u1 plus u2. This equation 5 is equation 5 in equation 1 you substitute. That means moment of equation. What is the moment of equation here? m1 u1 plus m2 u2 equal to m1 v1 plus m2 v2. So therefore write m1 u1 plus m2 u2 equal to m1 of v1 plus right v2 minus u1 plus u2 plus m2 v2. So again write here m1 u1 plus m2 u2, then expand this m1 v2 minus m1 u1 plus m1 u2 plus m2 v2 here. Now you can m1 u1 plus m2 u2 plus m1 u1 minus m1 u2, here common v2, m1 plus m2 into v2 here. Now write that same terms we can write it is m1 m1. So 2 m1 u1 plus u2 common m2 minus m1 into u2, that is m1 plus m2 into v2. Finally write v2 value 2 m1 u1 by m1 plus m2 plus m2 minus m1 by m1 plus m2 into u2. So this is equation 5. Equation 6. That means equation this will be the equation 5 and this will be the considered equation 6. So now these 5 and 6 equations after collision, v1 value this, v2 value this. If m1 equal to m2, masses are equal, what will happen? v1 is u2, v2 is u1. That means changing their velocity and traveling in a straight path.